Okay, this is the third method of solving systems of equations that we're going to talk about. This method is called solving with elimination. It's an regular old student favorite. You guys seem to like this method. I feel like you think it's easy. I like substitution. I think substitution is the easiest. You guys like elimination, seems like. Okay, multiply. Step one, multiply one or both sides by a number that will eliminate a variable. Let's see what I mean by that. Well, in this particular system right here, we're going to end up combining these equations down. And look, if I add 2x to 4x, I get 6x. But if I add 3y to negative y, all those y's are going to go away. That's why it's called eliminate. This one's going to eliminate the y's. Now, in this particular one, we don't have to do the first step because we already have a positive 3y and a negative 3y. They're already going to eliminate. We don't need to multiply one of the rows. The next step says combine the equations. So let's do that. Let's combine these equations. We didn't have to do anything for the first step. If I combine the two equations, I get 2x plus 4x is 6x. The y's are eliminated, and negative 6 plus 6 is 0. And then divide by 6, x equals 0. Okay? Now, so we solve for the variable, and we're going to plug that solution of x equals 0 into the simplest equation and solve again. Which one do you think is simplest? I tend to like to stay away from negatives. I think I'm going to, it doesn't matter. Ultimately, you can choose either or. I'm going to use this top equation. So I'll say 2 times 0 plus 3y equals negative 6. So 2 times 0 is 0, that term's going to go away. Then I can divide by 3, and then y equals negative 2. All right, and so this is a great way to display the solution, but also as an ordered pair, 0, negative 2 is a fantastic way to display the solution. Okay, what do you think, elimination method? Let's add a little rigor to the next problem. Let me give you a fun fact. It's called elimination method, right? Because we eliminate one of the variables. Well, there's a movement to change it. They think eliminating variables is a little harsh, maybe a little insensitive, because who wants to be eliminated? I don't know. So a lot of people are thinking of, have already started calling it the combination method. So if you ever see it called the combination method, well, it's called that sometimes. Let's try another one. Let's do 5x minus 2y equals 4. 2x plus 3y equals 13. I'm just kidding. It is called the combination method, but it's not because people were overly sensitive. Most people call it the elimination method. However, we'll tell you about when I was a kid growing up. We always like to avoid violence if we could. And like, you know, we started a slogan, me and my fellow mathletes, we would get picked on a little bit, bullied around a little bit. But we always thought that like this elimination method was a good way to solve systems of equations, you know, my math club and I. And whenever some bullies would come to pick on us or whatever, give us a hard time, we would just say, hey, eliminate, and then we would give them a system of equations to solve, and everybody would be all happy and everybody would win. All right, so multiply one or both equations by a number that will eliminate a variable, okay? So look, in this one, if I add the x's are not gonna eliminate, I'll get 7, okay? In this one, the y's are not going to eliminate. I would get 1 y. I need all the y's to go away. So, and there's not really anything I can, if I could somehow make this 2 a negative 5x, that would eliminate the x's. If I could somehow make this negative 2y, if I could make that a 3 by multiplying it by something, that would make it eliminate, but nothing's really going to, I'm going to have to multiply both equations by a number. So we're gonna look at, like, we can look at the x's, and we can find the smallest number that both 5 and 2 will go into evenly, which would be 10. So I can multiply this one by 2, which would be 10x, and I can multiply this one by -5, that would give me 10x here. Or, I always like to deal with the smallest number possible. So if you look at the y's, what's the smallest number that both 2 and 3 go into evenly? That would be 6. It's a little smaller than 10. So I think I'm going to eliminate the y's. What I'm going to do is I'm going to multiply everything on both sides of this first equation by 3. And I'm going to multiply everything in this second equation by 2. In doing so, I would get 15x minus 6y equals 12 from the first equation. And in the second equation, 2 times 2x would be 4x plus 6y equals 26. So now, look at this system. It's better because I have y's that are going to go away. When I combine the two equations, 15x plus 4x is 19x. The y's are going to go away. And that is equal to 38. Now, I can solve for x, divide by 19, x equals 2, and now I'm ready to plug 2 into the simplest of all the equations that you see up here. I think the simplest equation would be this one. What do you guys like about that one? All positive, pretty small numbers. I mean, this one's all positive, it's bigger numbers. We like positive, we like small numbers, those are easy to work with. So I'm gonna choose this one that I circled, and it's gonna be 2 times 2 plus 3 times y equals 13. So I get 4 plus 3y equals 13. Then if I subtract 4 from both sides, I get 3y equals 9. Divide by 3, and I get y equals 3. Okay. So my solution is x equals 2, y equals 3. Another great way to write it is in ordered pair, 2, 3. All right. That's the elimination method. That's the last method of solving. One more video for 4.1 where we talk about the different types of cases of a solution. I'll see you soon.